Imagine sitting down to take a math test, and the test actually changes its questions in real time. Like,
Yeah.
it's reading the speed of your mouse clicks or the specific way you hesitate before answering a question.
Yeah, tracking all of it.
And it even remembers the concepts you struggled with like 3 weeks ago.
Mhm.
I mean, it sounds like a scene from a science fiction movie, but this is the actual reality millions of students are interacting with today.
It really is.
Because for most of modern history, education has operated on this pretty simple, almost industrial factory model.
Standardized.
Exactly. One teacher stands at the front of a room, delivering one standardized lesson to 30 different students sitting in rows. And the brutal reality of that model is that the lesson leaves the station at a specific time. If you aren't fully on board, well, you just spend the rest of the year watching the train pull further and further away.
Yeah, I mean, it was a system built entirely for efficiency at scale. It was never built for individual human cognition.
Right.
We standardized the curriculum mostly because we just lack the technological capacity to, map and respond to the unique cognitive architecture of every single brain in the room.
We just accepted the casualties, basically.
Exactly. We accepted that some students would inevitably fall behind and others would be chronically bored. We just viewed it as the cost of doing business in mass education.
Well, welcome to another deep dive. To you, the learner, whether you are prepping for a corporate meeting, trying to catch up on a new industry trend, or just inherently curious about where the world is heading, today we are exploring a stack of sources that suggest this traditional factory model of learning is just completely shattering.
They're undergoing a massive shift.
It really is. We were looking at a fascinating mix of research today. We've got a landmark RAND Corporation study on personalized learning, the Center for Curriculum Redesign's comprehensive book on artificial intelligence in education.
That one's incredibly detailed.
Oh, yeah. Plus a massive systematic review from the International Journal of Educational Technology and Higher Education, and some really sharp insights from a joint UCL and Pearson report called Intelligence Unleashed.
And, the overarching theme binding all these incredibly diverse sources together is this fundamental seismic shift in how we approach the act of learning itself. We're moving away from a model of broadcast to a model of continuous dynamic interaction. And it's driven entirely by this massive collision of big data, high-speed computation, and cognitive science.
So our mission today is to cut through all that futuristic tech hype. We want to figure out exactly how artificial intelligence is rewiring the classroom right now, analyze the hard data to see if it actually works, and expose some frankly shocking blind spots regarding who is currently designing the future of your learning. Okay, let's unpack this. Before we look at the actual test scores to see if any of this is effective, we really need to understand how AI fundamentally changes the mechanics of learning for you as an individual.
Yeah, that is the crucial starting point. To understand the shift, we have to examine what researchers call adaptive learning systems.
Right.
Historically, when you wanted to learn something, you were handed a static textbook, or you sat through a static lecture. Material did not care if you were tired, confused, or, already an expert.
It was just a brick of information.
Exactly. But adaptive platforms like Khan Academy for Math or even language apps like Duolingo, they do something entirely different. They build what is known in the research as a learner model.
Which is essentially like a digital shadow of your brain, right?
Yeah, that's a good way to put it.
Because it isn't just a profile with your name and age. It is a constantly updating algorithm that tracks your interactions.
And it goes incredibly deep. I mean, the system records your quiz results, obviously, but it also tracks the micro interactions.
Like what?
Like, how long did you pause on question 4? Did you watch the video tutorial all the way through, or did you skip to the end? What specific sequence of algebraic steps consistently triggers your mistakes?
Oh, wow. So it's looking at the exact mechanics of where you fail.
Right. The learner model takes all that behavioral data and reshapes the very next lesson to match your specific cognitive state at that exact moment.
I was trying to visualize how this actually helps someone learn. And the UCL report brings up this foundational concept in psychology called the zone of proximal development, or ZPD.
Such an important concept.
Right. Think of ZPD like going to the optometrist. You sit in that chair and they flip different lenses over your eyes and they ask, better like this or better like this.
Yeah, trying to find that perfect focus.
Exactly. They are trying to find the exact prescription where the letters on the wall snap into perfect focus. ZPD is that perfect focal point for learning. The lesson isn't so easy that your brain just goes to sleep, but it isn't so difficult that everything is a blurry, frustrating mess.
Right.
You are challenged just enough to stretch your abilities, but you have the scaffolding you need to actually succeed.
And the tragedy of the traditional classroom is that a single teacher simply cannot keep 30 individual kids in their unique zone of proximal development for an entire hour.
It's just mathematically impossible.
Exactly. A teacher cannot flip 30 different sets of cognitive lenses simultaneously.
Hmm.
But an AI-powered adaptive system, it absolutely can. It does this automatically, continuously, for thousands of students at once.
And what really struck me in the sources is how this mechanism quietly revolutionizes the experience for students with specific learning differences.
Oh, this is a huge deal.
Right, like imagine a student with dyslexia who historically struggles to process dense paragraphs of text. In a traditional setting, they might just quietly give up in the back of the room.
Yeah.
But in an adaptive system, the AI actually notices the drop in reading comprehension speed, it cross-references it with their previous struggles, and it quietly offers the next module via audio delivery.
Just seamless adaptation.
Seamless. Or consider a student with ADHD who, routinely loses focus after 10 minutes. The system learns that threshold and automatically breaks their lessons into shorter 7-minute sessions with more frequent interactive checkpoints.
And the format of the information adapts just as fluidly as the pacing.
How so?
Well, some learners synthesize information beautifully through visual diagrams and color-coded charts, while others need a highly structured, step-by-step written explanation.
Right, everyone learns differently.
Exactly. The adaptive platform actively tests these different delivery formats, observes which one yields the strongest retention for that specific individual, and then weights future lessons toward that preferred modality.
That's incredible.
And the best part is the support arrives through the platform itself, completely free of the social stigma of having to raise a hand in front of 30 peers to ask for help.
Yeah, it's like swapping out a fixed train track for a dynamic GPS.
I like that analogy.
Because if you take a wrong turn in a new city, a GPS doesn't just leave you stranded, right? It doesn't force you to drive through a swamp to get back to the original route. It instantly recalculates and builds a brand new custom path to your destination based exactly on where you are currently standing.
That's exactly how adaptive learning functions.
But I do have to push back here.
Okay, let's hear it.
In theory, a hyper-customized cognitive GPS sounds like an absolute miracle. But does this hyper-customized GPS actually lead to better test scores? Or is it just a shiny, expensive new toy that tech companies are trying to sell to underfunded school districts?
Well, that is the ultimate test of the technology, isn't it? And it brings us to the empirical data in the 2015 RAND Corporation study.
Let's look at the numbers.
The researchers did not just look at a handful of isolated students in a lab. They examined academic achievement across 62 different schools that were actively implementing these personalized adaptive learning practices over the course of 2 full school years.
So a pretty massive sample size.
Very robust. And the findings were incredibly compelling. The students using these adaptive practices made significantly greater progress in both math and reading compared to a carefully matched group of peers attending traditional factory model schools.
Wow.
Yeah, the academic improvements were consistent. And highly importantly, they held steady across different demographic and income levels, which suggests the technology scales effectively across different socioeconomic environments.
But, the absolute most exciting nugget from that RAND study is what happened to the students who started the study already behind.
Yes.
We are talking about the kids who normally get left at the station in the traditional model, the ones who usually compound their deficits year after year.
The hardest group to reach.
Exactly. Those specific students actually caught up to perform at or above national averages.
It's remarkable.
They didn't just survive the school year, they completely closed the historical gap.
What's fascinating here is how those specific schools achieved those massive gains, because the RAND study makes it very clear that the technology did not generate these results in a vacuum.
Right, it wasn't just magic software.
No, the schools that saw the greatest achievement spikes combined the AI systems with highly deliberate human strategy.
Yeah.
The administrators didn't just plop the kids in front of glowing screens and tell the teachers to go take a long coffee break.
Right, because the teachers were actively using the data dashboards generated by the AI to drive how they physically group students in the classroom. They
Exact.
created flexible learning spaces, and most importantly, the educators actually sat down with the students, pulled up their individual data profiles, and discussed their progress with them. It gave the students active ownership over their own learning trajectory.
The AI is doing the tedious, high-volume, computational heavy lifting. It handles the automated grading, the massive data analysis, and the real-time pattern recognition. And by automating those administrative and computational tasks, the AI actually frees the teacher up to do the high-value, deeply human work of pedagogy.
Like the actual teaching part.
Right. Providing nuanced mentoring, offering emotional support, and executing targeted early interventions.
Yeah, imagine a teacher holding a tablet and knowing, before a unit test even happens, that exactly 4 students in the back row are currently stalling on a very specific algebra concept.
They'd know instantly.
The AI acts as a real-time early warning system. The teacher can just walk over and intervene at the exact moment of frustration, rather than finding out 2 weeks later when the student fails the midterm.
That technology automates the computation to save the human pedagogy.
Exactly. So we have established that adaptive learning can produce significant verifiable gains in K-12 math and reading when thoughtfully paired with human instruction.
Yes, the data is clear there.
So the natural next step is to examine what happens when administrators attempt to scale this technology up to address the wildly complex, high-stakes environment of higher education.
University level is a whole different ballgame.
Oh, completely. Because if you are going to map the brains of millions of university students to combat, say, massive dropout rates, you have to ask a fundamental question.
Who is building it?
Exactly. Who is actually building these incredibly powerful systems? We looked at a massive systematic review by Zawaki Richter and colleagues, which analyzed 146 different peer-reviewed research articles on AI applications in higher education, published over an 11-year period.
And the demographic breakdown of the people authoring that research is incredibly revealing.
It really is.
Out of those 146 articles driving the future architecture of university learning, 61 of the first authors came from computer science departments.
Okay.
Another 29 came from various STEM fields.
And do you know how many came from an education department?
It's a shocking number.
9. Just 9 out of 146 papers. We are talking about the complete redesign of higher learning, and the educators are barely even in the room.
This raises an important question. If the people building the future of education are predominantly computer scientists, software engineers, and data analysts, rather than pedagogues or cognitive psychologists?
What specific outcomes are they prioritizing?
Exactly, because an engineer inherently wants to optimize a path for algorithmic efficiency. But a teacher inherently wants to cultivate a mind.
Those are very different goals.
Very different. The systematic review breaks down the output of these computer scientists into 4 distinct categories of technology.
And the first category is profiling and prediction, which, think about the stakes of this.
It's intense.
Imagine a university administrator staring at a digital dashboard on the very first day of the fall semester. Before a single midterm is taken, an algorithm highlights 1 out of every 5 student names in bright red, predicting with shocking accuracy who will quit before their sophomore year.
Yeah, the review highlighted studies where artificial neural networks were trained to predict freshman dropout rates with over 81% accuracy.
Wait, 81% accuracy just from data?
Just from data.
Yeah.
And the mechanics of how those neural networks achieve that accuracy are quite profound. The algorithms are fed vast amounts of institutional data.
Like what kind of data?
We're talking demographic backgrounds,
Mhm.
financial aid status, high school zip codes, pass grades, and even how frequently a student logs into the virtual learning environment.
So every digital footprint.
Every footprint. The AI weighs hundreds of tiny variables. It might notice that a late cafeteria swipe combined with a missed financial aid deadline strongly correlates with academic withdrawal.
That is wild. And then the second area they're building out is intelligent tutoring systems, or ITS.
Right.
These go way beyond just adjusting the pacing of a math problem. They are designed to simulate actual one-on-one human dialogue.
The research highlights systems like MetaTutor.
Oh yeah, I read about that one.
Yeah, it teaches students about the human circulatory system, but it focuses heavily on supporting their self-regulatory processes. It literally prompts the student to reflect on how they are studying, rather than just what they are studying.
And there are also systems like StuA, which is an intelligent college assistant that handles all the administrative friction, answering queries about faculty office hours, exam schedules, and library resources.
Which leads to the third category, which fundamentally alters how we view academic assessment.
Automated grading.
Yes.
Yeah.
Automated essay scoring systems are utilizing machine learning and natural language processing to grade complex written assignments.
Which is crazy to me because for a long time, the consensus was that grading an essay required innate human empathy to understand subtext, nuance, and original thought.
Absolutely.
But the computer scientists figured out how to measure the mechanics of thought without actually understanding the soul of the essay, didn't they?
That's exactly what they did. The AI looks at sentence variability, vocabulary distribution, syntactic complexity, and semantic coherence.
And it works.
The research showed these algorithms grading postgraduate medical student essays and achieving an agreement rate with human raters of between 94 and 98%.
That is staggering. The machine doesn't actually know what it's reading, but it knows exactly what a good argument looks like structurally.
Yep. And the fourth and final area is the deployment of adaptive systems at scale. We're talking university-wide platforms recommending personalized content, dynamic learning pathways, and actually assisting professors in restructuring entire syllabi based on real-time cohort data.
Here's where it gets really interesting.
Okay.
I look at that list of what the computer scientists are building. Neural networks profiling students on day one, algorithms grading essays by measuring syntax, digital assistants handling the dialogue. And I can't help but wonder about the core philosophy here.
The underlying intent.
Yeah. If technologists treat education purely as a data mining exercise to be optimized, aren't we risking the loss of the pedagogical soul of learning?
It's a major risk.
Because a highly optimized platform without a human teacher to guide the nuance, to provide empathy, and to inspire original thought, well, that's just a wildly expensive digital worksheet.
The Zawacki-Richter review exposes a glaring blind spot in the research that validates that exact concern.
What did they find?
Out of the 146 papers they analyzed, papers actively designing the future of university learning architecture, mind you,
Yeah.
only 2 critically reflected on the ethical implications or the potential risks of deploying AI in education.
Only 2. At 146.
Just 2.
We are literally wiring up the cognitive development of millions of students to these algorithms, and the builders are so focused on whether they can optimize the system that they aren't pausing to ask what could go wrong when they do.
And the sources outline several massive vulnerabilities when we leave the human context out of the training data.
Right.
The most immediate vulnerability identified by researchers like Holmes and colleagues is algorithmic bias.
Because the AI isn't objective.
Exactly. AI systems are not inherently objective. They learn by finding patterns in the historical data they are fed.
Right.
If an AI system is trained on historical data from an educational system that has already provided unequal access to quality instruction based on socioeconomic lines, well, the algorithm will invariably encode, automate, and scale those existing inequities.
And the mechanism of that bias is terrifyingly simple, isn't it?
Unfortunately, yes.
Like, if a neural network is trained on a decade of data where marginalized students historically dropped out at higher rates due to systemic underfunding or lack of resources, the AI simply registers that demographic marker as a risk factor.
There's no context.
Right. It looks at a brand new student from that same background, pattern matches them against the historical failure, and flags them as a dropout risk before they even take their first exam. The algorithm mistakes a systemic historical failure for an individual student's profile.
And then the second major vulnerability is the sheer scale of data privacy and surveillance.
Oh, this part is unsettling.
We are moving far, far beyond a simple report card here. These adaptive systems compile a real-time, highly granular psychological profile. They monitor how long you hover your mouse over an incorrect answer. They catalog the specific concepts that cause you to hesitate. And they track what time of day your cognitive attention flags.
And who owns that psychological profile?
That is the million-dollar question.
Right. Does the university own it? Does the tech company that built the algorithm own it? Does your algorithmic tendency to give up on complex math problems after 10 minutes follow you to your first corporate job interview?
The current ecosystem has very few guardrails in place to answer those questions.
Which is terrifying.
If we connect this to the bigger picture, the final vulnerability is the exacerbation of the digital divide.
Yeah, the hardware aspect.
Implementing these AI-powered adaptive learning ecosystems requires massive, continuous infrastructure. It requires high-speed broadband, individual devices for every single learner, and expensive ongoing software subscriptions.
And the cruel irony is that the underfunded schools, the ones that could theoretically benefit the absolute most from having an AI tutor help close their historical achievement gaps, are exactly the schools that cannot afford the infrastructure required to run the programs.
Exactly. And the Center for Curriculum Redesign's book puts out a very stark warning about this exact crossroads.
What do they say?
They argue that the collision of massive data collection, high-powered computation, and daily education has incredibly far-reaching consequences for society. We basically have two choices.
Okay.
We can leave it entirely to the software engineers and big tech companies to decide how artificial intelligence unfolds in our classrooms, prioritizing efficiency, surveillance, and prediction.
Right.
Or we can engage in a productive, critical dialogue to demand that these tools are built from the ground up to serve human teaching.
Which means getting the educators involved.
Yep. It requires educators, cognitive psychologists, and ethicists to step into the room with the developers. The technology is brilliant, but an AI is only as smart as the data used to train it. Without the human context informing that data, the smartest systems can make highly efficient, very damaging mistakes.
So what does this massive shift mean for you, the learner? Let's synthesize the journey we've been on. Artificial intelligence represents a paradigm-shifting leap away from the standardized factory model of the past.
Huge leap.
It possesses the incredible ability to map your brain's unique cognitive pathways, flip the metaphorical lenses until the material comes into perfect focus, quietly provide scaffolding exactly when you need it, and free up human mentors to do the work that actually inspires us.
But as long as this technology is being developed primarily as a tech-first endeavor, you must navigate it with a sense of critical awareness. Because whether you are a university student logging into a portal, a professional catching up on a new coding language, or just someone trying to learn conversational Spanish on your daily commute, you are already interacting with these hidden learner models.
They're already there.
They are. And understanding the mechanisms behind how they track your clicks, assess your hesitations, and predict your outcomes makes you a vastly more empowered learner. You can use the algorithm as a tool to expand your capabilities, rather than letting the algorithm quietly dictate your limits.
Which brings me back to the GPS analogy from earlier.
Yeah, the dynamic routing.
As these adaptive systems inevitably get better, incorporating features like emotional recognition to detect through your webcam when you are getting frustrated and instantly making a lesson easier to soothe you.
It's coming.
We have to ask ourselves a fundamental question about the nature of growth. Is making learning perfectly frictionless always a good thing?
That's a profound question.
Or is the cognitive struggle, the deep frustration, and the hard-won eventual breakthrough actually the exact place where true resilience and genuine understanding are formed?
Right.
If the GPS always automatically routes you around the traffic and the confusing intersections, do you ever actually learn the streets of your own city?
Wow. Yeah, the concept of desirable difficulty is the very definition of profound learning.
Exactly. Something for you to think about the next time an algorithm tries to make your learning journey a little too easy.
It is a vital question to keep in mind as we navigate this new landscape.
Thank you for joining us on this deep dive into the architecture of your own mind. Stay curious, stay critical, and we'll see you next time.
Take care, everyone.